Hello there guys, welcome back to another epic and extra maths video. We're doing another video on improper integrals. This time we have two integrals, and this is actually, it's going to be worth watching guys. It's going to be worth watching this video because we're going to find out that even though these two integrals look very similar, the only difference is the power of x, of course, on that denominator. They're actually going to yield very, very different answers, okay? And we're going to see there's a big difference between these two things. So let's just start off with the first one, the integral from 1 to infinity of 1 over x squared. So I'm going to draw it again just to allow us to visualize this. Okay, so here's our x-axis and here's our y-axis. And then I'm going to draw the graph. So the graph of y equals 1 over x squared, at least the positive side of it, the part of it that's to the right of the y-axis, looks a bit like this. Okay, where we have asymptotes on the y-axis and the x-axis. Maybe the point 1 is about there, the x value 1. And again, we're going to do what we did last time, so link, by the way, in the description to the last video if you haven't seen it. I'm going to just define some value t, in this case it's going to be bigger than 1 there. And then I want to find an expression in terms of t for the area between these 2 points. And then I'm going to let t go to infinity and see what I get, okay? Hopefully that makes it. Imagine that t coordinate going further and further down the x-axis. What does that get closer and closer to? So this one here, okay, we're going to write the limit. Always write the limit, guys, it's really important. You got to write the limit every time. The limit, as t approaches infinity, of the integral from 1 to t of 1 over x squared with respect to x, okay? This is the limit as t approaches infinity of, and let's just do the integral, okay? And by the way, 1 over x squared, of course, maybe it's easier for our integration purposes to write this as x to the power of minus 2, and then do the integral. Well, what does x to the minus 2 integrate to? Last I checked, it was minus x to the minus 1. And again, the limits are 1 and t. Okay, and then I'm just going to come down here, guys. So it goes like 1 and then to the side, and I'm going to go down again, okay? The limit as t goes to infinity of, and then let's evaluate the integral. So let's actually plug some stuff in. So minus t to the minus 1, subtract minus 1 to the minus 1, okay? Close bracket. Now, of course, we can simplify this slightly, but the most important bit is figuring out what happens to this function as t goes to infinity. Right now, this is an expression for that area over there in terms of t. So the bigger you make t, in theory, the bigger the area should be. But is there a biggest area? As t goes to infinity, will the area converge to a particular value? Well, yes, it will. So just to be clear, as t approaches infinity, minus t to the minus 1, what is that going to approach? Well, remember, t to the minus 1 is 1 over t. So we're dividing by a bigger and bigger and bigger number. That's going to be 0. And the minus is irrelevant. So this is 0. So minus t to the minus 1 approaches 0. But there's also a 1 to the minus 1. 1 to the minus 1 is just 1, guys. So we can kind of just ignore that. And then, of course, minus and a minus, that's actually going to be a plus overall. So it's 0 plus 1, which is 1. So what this is saying is as t approaches infinity, if I was to try and, kind of draw this a little bit differently, and I was to have the area just keep going on forever and ever and ever and ever, that area approaches 1, okay? Just 1, just 1. It never exceeds it. No matter how far along the x-axis you go, the area is 1. Okay, now you might think, okay, well, our other integral over here should probably give us a similar value, right? Because it's very similar. But actually we're a bit mistaken because that's not going to happen. So let's go and do this guy over here. So again, I'm going to do the same process. Maybe I'll do it a little bit faster for you guys this time since we've already seen something very similar. Limit as t approaches infinity of the integral from 1 to t of 1 over x. Now guys, what does 1 over x integrate to? Well, 1 over x integrates to the natural log of x. Okay, And I've not written the absolute value on that just because everything's already positive, so it doesn't matter, okay? So just plugging stuff in. We've got the natural log of t minus the natural log of 1, okay? But by the way, guys, the natural log of 1 is the number 0. That's the number 0, so I'm just going to ignore it. And so we have the limit as t approaches 0 of the natural log of t. Well, the natural log of t, as t goes to infinity, actually just goes to infinity as well, okay? Just to show you, if this is the t-axis, then the natural log of t looks like this. Now, it looks like maybe there's an asymptote up there or something, but there's not. This does just keep going up and 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 up. You'd have to draw it very long, but it does keep going up. There is no maximum value. There is no asymptote here. So the bigger t is, the bigger the natural log is, without any bounds, any limits. So this is infinity. So as t approaches infinity, the natural log of t approaches infinity, which means that the area underneath the graph, which I haven't drawn yet, is infinity. Oh no. So just to do a quick picture of it, x-axis, y-axis, it actually looks really similar to the last one that we drew, right? There you go. That's y equals 1 over x. It looks very, very similar, but mathematically it's quite different. And again, if this is 1 and this is t, we do run into an issue. This area here is the natural log of t, okay? But as you make t bigger, yikes, because the natural log of infinity is infinity. So the area underneath this is not finite. It does not converge to a number like how the other one did. It converged to the number 1. This is actually infinite. And we say that this diverges, okay? So if the area is finite, then it converges, which I'll write over here. But if it's infinite, then it diverges. And so big, big differences between very similar functions. Thank you guys so much for watching. I highly appreciate it, as always, and I'll see you in the next video. Cheers.